This is Vinayam here. I'm going to discuss about periodic classification of elements. Study of 118 different elements and its properties is really a very elaborate and tough job. To make our work easier and to understand the properties of different elements better, it is easy to classify them into different groups. Different arrangement of elements were suggested in this regard over the years. The classification was initially done based on atomic masses and now it is based on atomic numbers. The first type of classification was done by Anthony Laurent Lavoisier. In the year 1789, he defined a chemical substance as something that could not be broken further, and he listed 33 different substances coming under this definition. He classified them into 4 different categories: gases, nonmetals, metals, and earth. But this is no longer relevant. We are going to briefly discuss the genesis of periodic classification. Johann Dobereiner in 1829 made a significant classification. He noted the similarity among the physical and chemical properties of several groups of 3 elements. He called them as triads. He could identify 3 different triads. First one, lithium, sodium, potassium. Second one, calcium, strontium, barium. And third one, chlorine, bromine, iodine. What is special about the triads? He found out that the atomic masses of the middle element is having the average atomic masses of the other 2. So this is true for sodium, strontium and bromine. But he could classify only 9 different elements in under this, and so later on it was discarded. In the year 1865, John Alexander Newlands propounded the law of octaves. Newland arranged the different elements known at that time in the increasing order of atomic weights and noted that the 8th element has similar properties to that of the first, just like how the octaves in music behave. But this law was found to be true only for elements up to calcium. This is the Newland's octaves. Here you find that the rare gases are not included. That was not discovered at that time. In the year 1869, Dmitri Mendeleev made a remarkable classification based on atomic masses. He did this after his Mendeleev's periodic law, which states that the physical and chemical properties of elements are periodic functions of atomic masses. The important point here in Mendeleev's periodic table is that he kept provision for the yet to be discovered elements. Following that, many suggestions were made for periodic table. One such one is circular periodic table. Whimsical periodic table by Romanov in the year 1934. What we follow now is the modern periodic table, which was put forward after the discovery of modern periodic law, stated by Henry Moseley. It states that the physical and chemical properties of elements are periodic functions of the atomic numbers. That is, with increase in atomic number, the position of the elements keeps on changing. What are the important points in modern periodic table? The horizontal rows in the modern periodic table are called periods. The vertical columns in it are called the groups. There are 7 periods and 18 groups in the modern periodic table. And so, the modern periodic table is also known as long form of periodic table. Elements in a group have some properties in common. The shortest period in the modern periodic table is the first period, which consists of 2 different elements, hydrogen and helium, whereas the longest is in the 6th and the 7th period. The filling up of electrons in different orbitals follow the rules of Bohr principle, Hund's rule of maximum multiplicity, Pauli's exclusion principle, and extra stability of half-filled and fully filled orbitals. Some more points to be remembered in modern periodic table. There are 4 important blocks in modern periodic table. They are S block, P block, D block and F block. S block and P block elements together are known as representative elements. The D block elements are known as transition elements, as they are the bridging elements between the typical metals present in S block and non-metals present in P block. The F block elements are present in between the transition elements, and so they are known as inner transition elements. Now we shall learn the different steps to locate an element in the periodic table. First, write the electronic configuration of the element. Find out the highest n value. The highest n value gives the period number of the element. The valence electrons decide the block to which the element belongs to. In case of S block elements, the group number is the number of electrons present in the ns orbital, whereas P block element is the one in which the group number will be equal to 10 plus ns plus np electrons. In the case of D block, the group number is ns plus n minus 1 d electron. So we shall try to locate the position of element with Z value 13, that is atomic number is 13. First, write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p1 is the configuration. N value is 3 here because that becomes the highest n value. So period number is equal to 3. The valence electron enters the p orbital, so it belongs to p block. In case of p block, we have learned that the group number is found by adding 10 to ns and np electrons. So we get the answer as 13. So it belongs to group 13, and the element that is found is aluminium in the P block in the 13th group and 3rd period.